So now in this video we're going to look at using a weak signal source. So this is a 5-volt power supply here, and this is just a demonstration circuit. This is not really a practical circuit. I don't need to do this, but the workings of this circuit can be applied larger scale, which aren't as obvious but more useful. So in any case, we're going to use this 5 volts as a signal to control this 18 volt. So of course you can't see the voltages, but the power supply here, got that backwards, is 5 volts there, and it's connected ground to ground only to this rail here, and my bench power supply is providing 18 volts to this rail. So right now this rail is powering this LED circuit. These are both 2,200 ohm resistors. They're in parallel, so we get twice the current because each one of these resistors, right now there's 18 volts across them, and their wattage is about the maximum you want to use for long periods of time. So in any case, we have the LED right now being powered by the bench power supply, and the way we have it wired right now, I have to turn the bench power supply off and on to turn the LED on, my 18 volt bench power supply. And so what we're going to do with the breadboard power supply, so first off I'm going to yank this jumper. These resistors are really hot. I really don't want to touch them until they cool down. And we're going to go down 2 more rows, and there we go, to the negative rail there. And so we just opened the circuit. The bench power supply is still on, and we should be okay wiring this up with the bench power supply on. So in any case, it's best though whenever you wire stuff to turn the power supply off. So we have the NPN transistor here. This is a 2N2222 NPN type bipolar junction transistor. The left pin is the emitter, middle pin is the base, and right pin is the collector. Since we're going to use this as a switch, which is probably the best use in this particular case when you're using a small signal to control a larger power supply, we're going to put the load on the collector side. So we're going to wire it as a switch. We don't want, when we give the signal to the emitter, or to the base I mean, it's going to go to the emitter. We want that to go directly to the negative rail and back to the other power supply. So we will just wire it there, collector, top pin there, to the cathode, short lead of the LED. So there we go. And power is applied. It is off right now. So we need to give the base a signal, the middle pin of the transistor. So I'm going to, I could have did this before I went back, put a jumper right there, and since the power supply is on, you might notice something interesting. When I touch the jumper, and I went down 1 row by accident, but I'll leave it there. When I touch the jumper, you can see the LED turns on a little bit. That's because my body is giving the transistor a small signal. So nowhere near enough to get the transistor to conduct fully, but enough to get it to conduct a little bit. It's amplifying. I'm providing a little current through the base to emitter because I'm picking up electrical magnetic fields around me, and so I'm able to produce enough electricity to light an LED a tiny bit with a transistor. Let's turn the light down. So there we go. So if we had turned off the power supply like we should have, that wouldn't have happened. But in any case, that's a learning experience, and it doesn't damage anything, so it's kind of worth it. So in any case, let's zoom back. So here I have a switch. One side of the switch comes to the positive rail. These push button switches, they connect across the top. So if I attach something there, it will be connected to the positive side of the power rail at all times. It's separated from top to bottom. And so we're going to take a resistor here, and resistors are nice because they go across the board pretty well. And there we go. So right now, again, it's my body providing that signal. I'll turn the light down. You can see the LED lighting up. But otherwise, we have our completed circuit. So right now the transistor is a switch, and so when I press this button we give an actual semi-strong signal. Still, this is a 10 kilo ohm resistor, 10,000 ohms of resistance. These two are in parallel, so they have an equivalent of 1.1 thousand ohms of resistance. So we got 10 times the resistance coming from a lower voltage power supply. So it's a weak signal, but there you can see the LED turns fully on. So these are both 2200 ohm resistors. Don't use lower value ones with 18 ohms, but they're in parallel. So each one's going to pass current as if the other one doesn't exist, and so the current will be doubled. It's like having half the resistance. But in any case, right now we barely take any power from the breadboard power supply, and of course we can light an LED with it directly if we want to, but for whatever reason we like this setup of components and the 18 volts, but we don't have a switch that can handle 18 volts or whatever the reason. There's different reasons. You'll come across reasons. You have a weak signal, you want to control a load that it can't handle by itself, and this is one way you can do that, especially if you only need a switch. So now this transistor can only handle, this is a 2N2222, probably 500 milliamps of current, 600, like that's absolute maximum. You want to keep it lower. There's power transistors that can handle more. You may hear a little popping noise once in a while. The switch gets pushed out of the breadboard. Breadboard pushes the switch out, and that's not too bad, because that means that the holes aren't getting worn out, but you can't rely on the switch staying in there. Same with the trim pot that I used before. One of them got pushed out easy, another one stuck in there easy. So in any case, main takeaway, small signal controls a large power and load, and so that's one way to protect your signal source, because all your signal source has to do is provide a little bit of current to, in this case, a transistor. You could also use a relay, and they're a little less obvious how to wire up though, and so I mostly use transistors. And also transistors last forever. There's no moving parts, and so almost forever, as long as you don't put too much current through them. So in any case, hopefully this video was helpful and you can apply it sometime. In fact, let's look at how much current we got going through here just for fun, and I will set this to milliamp. So of course right now it's off, so no current's gonna flow. So I got the two probes there. See if I can hold it with one hand, and I'll press the button. Now you can see it's about 16 milliamps of current. So the LED is going to be pretty much as bright as it can get safely. So you don't want to put more than 20 milliamps of current. So we have about 16 right there. Now the resistors shouldn't be too hot. They haven't been on too long. I'm going to yank one out, and you can see that now we have half the current. So two resistors in parallel gives you twice the current. Let's see if I can wire this and push the switch. Not really. Okay, but you would have seen the LED get a little bit brighter when, oh, I didn't attach it. I'm off a row, that's why. There we go. So LED, watch the LED. Let's turn the light down. It'll probably show up better. So it's brighter. When I yank this, it'll get dimmer, and you should have been able to notice that. So in any case, that's all topics for different videos. I thought I'd touch on that a little bit more in this one, but we're out of time. This video is going pretty long. So hope you enjoyed all this. Thanks for watching, and I will see you in the next video.